And final question. Healthy human blood needs to be maintained at a pH of 7.4 for the body to function normally. Carbonic acid is a weak acid which, together with hydrogen carbonate ions, acts as a buffer to maintain the pH of blood. The pKa value for the association of carbonic acid is 6.38. Explain in terms of equilibrium how the carbonic acid hydrogen carbonate mixture acts as a buffer in the control of blood pH, and calculate the HCO3 minus to H2CO3 ratio in healthy blood. 6 marker. So this is one of your level of response questions. So for a level 3, 5 or 6 mark answer, you have to have included everything that's going on in here, explaining the equilibrium shifts, how it acts as a buffer, and carrying out the calculation. So there's 3 different areas to look at. Now, whenever you're dealing with a buffer question, explaining the action of a buffer, it's the same principles all the way through. There's a standard response you can give, regardless of the context. This is the context of blood buffers, but it doesn't really matter. If you're asked about the action of a buffer, you talk about what the buffer is, how it was made, or not necessarily how it was made, what is found in the buffer, and what happens when you add an acid to it, and what happens when you add an alkali to it. And then relate that then to the shift in equilibrium as a result of those additions. If you talk about that, will get you a level 2 answer, and then the calculation pushes you into level 3. So, any buffers question, I will always start by writing the equation for the buffer. So what have we got? H2CO3 is my weak acid. Associates into hydrogen ions, and I don't need the square bracket, excuse me, rub that out. HCO3 minus ions. So always write your buffer equation just so you can see what's going on. Okay? And start then by the addition, by adding hydrogen ions. So you talk about the action of the buffer. All right? You can even say what a buffer does, which is what a few of you did. A buffer minimizes the change in pH. Okay, on the addition of hydrogen ions or hydroxide ions. So for adding hydrogen ions, say what it does, and then explain how that changes the equilibrium position. So an addition of hydrogen ions, the concentration of hydrogen ions increases. The hydrogen ions react with the conjugate base. In this case, it's HCO3 minus. So therefore, the combined reaction of these two is the production of this. So equilibrium shifts left. So say what happens, explain what reaction is taking place, and then state which way the equilibrium will shift. Now repeat that process again for the addition of hydroxide ions. And the mistake that a few people made when trying to do this bit, they talked about the addition of the hydrogen carbonate. That's not what you're doing. A buffer is about using these chemicals, these ions present, to counteract the addition of any acid or alkali, not more of what you've already got in there. So the additional hydrogen ions are not the same hydrogen ions that's associated. This is another acid that may be added to your buffer. So in this case, what are we doing? Addition of hydroxide ions. The OH minus ions react with H plus. What's that going to do? We're going to be using up the H pluses, so the concentration of H plus will decrease. As a result then, the equilibrium wants to put that back, the equilibrium will shift to the right. To try and replenish, so we get more dissociation of the H2CO3 to replenish the hydrogen ions. So that should be enough to satisfy the explanation of what the buffer is doing. So when you look at the mark scheme for this section, a level 2 answer for 3 or 4 marks is a detailed explanation of the equilibrium and the action of the buffer. So what you're doing there is the equilibrium are the comments on the shifts. The action of the buffer are the comments on what happens as you add the different chemicals in. So the first 2 statements there and the first 2 statements there are the action of the buffer, and the equilibrium shift then is the equilibrium shift. So the final section for this question is the calculation. So calculate the HCO3 minus H2CO3 ratio in healthy blood. So what we've got is a pH of healthy blood at 7.4 and a pKa value giving us the dissociation constant for the carbonic acid. So I've got two conversions to do. Now, remember your expression. Ka equals H plus, concentration of H plus, multiplied by the concentration of the conjugate base, HCO3 minus, over the concentration of H2CO3. Now, in the question, we have been given a pH. So from the pH, we can determine the concentration of hydrogen ions. We've also been given the pKa, so conversion of this will give us Ka. So we have two of our four values, leaving us then with this ratio here, HCO3 to H2CO3. So a quick rearranging of my expression would leave me with Ka over H plus equals that ratio of HCO3 minus over H2CO3. So if I can get these two values from my logarithmic values here, the 7.4 and the 6.38, and actually do the division, so the Ka divided by H plus will give me the HCO is equal to HCO3 over 1. So that is what I'm looking for, and that is therefore my ratio. So if I use this space at the top here, a pH of 7.4 is going to give me, if I do 10 to the minus 7.4, will give me the hydrogen ion concentration, and that is 3.98 times 10 to the minus 8. And the same thing, pKa of 6.38 will give me 10 to the minus 6.38 to convert, which equals 4.17 times 10 to the minus 7. So if I put those numbers into my expression, the Ka value therefore is 4.17 times 10 to the minus 7 divided by the hydrogen ion concentration, which is this one up here, 3.98 times 10 to the minus 8. It's equal to the ratio. So if I do the division, that will leave me with 10.48 over 1. So your ratio, therefore, of HCO3 to H2CO3 is 10.48 to 1. And there's your final marks for this question. So remember, the 6 markers do not necessarily have to be written as an essay. All right, as long as you lay them out in a logical manner and it's clear what points you're trying to get across, then there's no problem with bullet pointing your key facts, your key statements for those 6 mark questions. And that then concludes your mock walkthrough. Please feel free to come and speak to any of the 3 chemistry teachers if you want any more clarity on the questions, and be prepared for future tests. Thank you.